Very good morning to one and all. Today I am going to discuss with analytical chemistry part under Unit 1 Introductions and Statistical Analysis. From this unit, we learn the concept of introductions to analytical chemistry, types of analysis, qualitative analysis and quantitative analysis, classifications of analytical methods under classical and instrumental. Finally, basis of their classifications with examples. The objectives of the units are mentioned here. From these units, we learn the broaden your perceptions of the field of analytical chemistry, the distinguish between that various analytical techniques, classify that electrical, optical, nuclear and thermal methods of analysis, classify the separations methods, and learn the utility of analytical techniques. Finally, development of methods of chemical analysis. Now we are going to discuss with introductions of this analytical chemistry. We know that it is a type of chemistry or it is a sub-discipline of chemistry with interdisciplinary character. Consider the daily life. We consider food which contains the chemicals, clothes, medicines. These are all the everyday generally we are using. In that food which contains that some chemicals like that vinegar which contain acetic acid or artificial sweeteners, cloth. Generally it is a plant substances or materials like cellulose to improve the hardness or to strength of that fabric. Generally we are using a chemicals, manufacture of medicines. We all know that the importance of this chemical analysis in all these products. The development of methods for chemical analysis lies in the provenance of analytical chemistry. Therefore, in this unit, first we will learn about analytical chemistry and its importance. Then we will study about that different chemical methods of analysis like the gravimetric and volumetric analysis. In this unit, we'll also discuss with classifications of electrical methods of analysis, which include instruments like potentiometry, amperometry, voltammetry, coulometry, etc. In the later part of this unit, we have introduced to optical methods of analysis like emissions, absorption, ultraviolet, infrared and Raman spectroscopy. We have also discussed the nuclear and thermal methods of analysis. Briefly, separations of the chemical compounds, is a very important part of analytical chemistry. In the last, you will study emerging needs and recent trends of analysis. Next, in our daily life, we cannot help but use of chemicals. Chemicals are clothes we wear, medicines we take, and immense variety of the substance we use. As a chemist, whenever you see a materials, to curiosity questions are raised in your mind. What is it and how much? The answers of these questions is given by chemical analysis. Chemical analysis, you are able to analyze compounds to see what and how much of a given compound constituent they contains in that chemicals. However, before an analysis can be made, a method must be available. The development of methods for chemical analysis lies in the provenance of analytical chemistry. What are the different analytical techniques generally we are using? Nowadays, so many analytical techniques we adopted in that chemical analysis. Under that, the very important types of analysis are involving in that analytical chemistries are chemical methods of analysis, electrical methods of analysis, optical methods of analysis, nuclear radiations methods of analysis, thermal methods of analysis, and separations method. These analytical techniques are adopted in that to analyze that chemical compounds in that analytical chemistry. These methods are further classified into different techniques depending on the measurement of characteristics properties based on either the nature or the amount of the desired constituent of the samples. In that classifications of chemical methods of analysis, these methods are based on that primary role of a chemical reactions. In these methods, the direct measurement of the mass is carried out by one of the two procedures, that is by weighing or by measuring volume. The corresponding methods are known as gravimetry and volumetry. Both of these being developed at early stage are now also known as classical methods of analysis. Consider that gravimetric. That gravimetric analysis means analysis by weight and pertains to all determinations wherein the final results are obtained by means of the analytical balance. The gravimetry is an accurate macro analysis procedure which mainly depends upon precipitations of an inorganic or molecular substance on the basis of chemical reactions. The precipitate is then separated, dried, and weighed in the suitable form. The amount of the desired constituent, means analyte, is then determined by simple calculations. At undergraduate level, you have estimated barium as barium sulfate the following gravimetric analysis techniques. That volumetric techniques, the amount of analyte can also be found in another way by measuring of the volume. Means that in titrations method, the method based on accurate measurement of volume of a reagent solutions of accurately known concentrations taken for a reaction known as what? Volumetric analysis or simple titrations method. The measurement of volume makes considerable saving of time. The greater speed of volumetric analysis is an important advantage of these methods over gravimetry. You know that titrations and its techniques. The volumetric analysis is characterized by a titrations. Hence, the method is also known as titrimetry. In this method, a known volume of reactant substance is taken in a beaker and titrant is added from that burette to it till the reactant completely reacts with the titrant. We call it as the equivalence point, which is indicated by an indicator. The volume of the titrant required to reach the equivalence point is noted on the burette. Means that is what? Titrant value or concordant burette reading. Calculations is made to get the amount of constituents of the reactant. By substitute that equations, finally we are getting that what is the exact concentrations or product of that reactant. That the classical methods of analysis. From this classifications of electrical methods of analysis are listed here. That electrical method of analysis, also known as electroanalytical methods, can be defined as on which electrochemical property of a solution is measured. A classification of electroanalytical methods can be made by measuring different electrical quantities such as the potential, current, quantity of current, resistance and dielectric constant. These methods have different names on the basis of the measurement of these quantities are stated below. That potentiometry, amperometry, voltammetry, coulometry, conductometry and high frequency methods. These are all coming under in that classifications of electrical methods of analysis. Now we are going to discuss with what is potentiometry. That analytical methods based on the measurement of potential difference across an electrochemical cell to interpret the results of an analysis are designated by the term potentiometry. The term potentiometry is derived from the word potential, which is half cell potential, obtained by measuring voltage across an electrochemical cell with the help of a standard electrode. The result of this analysis can be computed directly from the voltage of the cell or equivalence point of a titrations known as potentiometric titrations. In potentiometric titrations, we discuss Redox reactions curves based on Hawk cell potentials and describe the necessary procedures to obtain the sample analyte in the correct oxidation state for titrations. It is a special class of potentiometry where the potential of an indicator electrode is measured as a function of hydrogen ion concentration is designated as pH metric by suitably modifying the common voltmeter to high impedance millivolt meter, usually making use of glass electrode as a hydrogen ion indicator electrode. Suitable pH meters can be designated to measure pH instantaneously. That amperometry designated methods involving current measurements. The term amperometry is derived from the word ampere. Ampere is what? It is a unit of current. From these amperometric methods are generally applied to detection of equivalence points of titration, and method is known as amperometric titrations. Next we'll coming to the point of voltammetry. In voltammetry, an electroactive species is consumed. It undergoes both oxidized or reduced only at the surface layer of the indicator electrode in an electrolytic cell. The resulting current due to electron transfer process is measured as a function of applied potential. The current versus potential curves are plotted. These curves are known as the current voltage curves or current potential curve. Simply that is IE curves. I means current, E means voltage. The shape of the IE curves depends on the polarization of the indicator electrode, whereas the other electrodes known as the reference electrodes remains non-polarized. In voltammetry, we study the relationship between the current and electrode potential and its applications to chemical analysis. Next, colorimetry. It is a different types of analytical methods to measurement of quantity of electricity or designated by the term colorimetry. The term is derived from that coulomb. Coulomb is the unit of that watt current, quantity of current. A fundamental requirement of all colorimetric methods is that the species determined interacts with 100% current efficiency. The colorimetry is performed by two general techniques. One is the colorimetry at constant potential known as potentiostatic colorimetry and colorimetry at constant current known as amperostatic colorimetry. Next we look at that classifications of optical methods of analysis. In that optical methods of analysis, we have to study that substances or subsections we will the study of optical methods. Consider these methods also called the spectroscopic methods of analysis. In these methods, the first instruments were developed for use of visible region. Generally, we are using here UV regions, therefore called optical methods. This term has by no extended to other regions of EMR as well. All spectroscopic methods are based on the interactions of electromagnetic radiations or quantized energy states of the matter. Here, we study the measurement of a quantity based on that emission, absorption, scattering, or change in some property of electromagnetic radiations depend on the nature or the amount of constituent of the sample. The classifications may be based on the either type of effect, like that emission, absorption or scattering, or the type of EMR. EMR means electromagnetic radiations, like that X-rays, UV visible and IR used. The important spectroscopic methods are mentioned here. What are the important spectroscopic methods? Emission spectroscopy, absorption spectroscopy, ultraviolet and visible absorption spectroscopy, infrared absorption spectroscopy, fluorophotometry, turbidimetry and nephelometry, and Raman spectroscopy. These are all important spectroscopic techniques. Generally, we are using in that to analysis of these chemical substances. Under that, the first one, emission spectroscopy. Emission spectroscopy.
ಸರ್ ಆನಾಗಿದೆ ಇದು
ಬರ್ತಾ ಇಲ್ಲ. First we learn that emission spectroscopy. That emission spectroscopy is a method where the characteristic spectrum produced of elements is applied to qualitative and quantitative analysis. In these techniques, generally we are using electromagnetic radiations produced when the analyte is excited by thermal energy. Each of the element has a characteristic emission spectrum. This is applied to qualitative analysis. The quantitative determination is also possible to find in that emission spectroscopy. During this, the burning of the sample under controlled conditions, the energy emitted for a given spectral line of an element is proportional to the number of atoms that are excited and consequently to the concentrations of the element in the sample. This is the concept of emission spectroscopy. Generally asking in that 2 more questions, write a note on emission spectroscopy. This is enough. Next we will move on to that absorption spectroscopy. Absorption spectroscopy is based on the measurement of the absorption of electromagnetic radiation by matter. Absorption means or refers to a process which a chemical species is transparent medium selectively absorbs the photons of certain electromagnetic radiations. The absorption varies with the wavelength of incident radiation. Measurement of absorption can be made at single wavelength or over a wide range of wavelengths. When selections of a narrow wavelength range is made with help of filters, the analytical techniques known as filter photometry. When the measurements are made approximately monochromatic radiations obtained with the help of monochromator. Generally we are using monochromator substance, the prism or grating, The techniques is known as spectrophotometry or absorption spectrometry. Next, ultraviolet and visible absorption spectrometry. It's a type of analytical methods to involve the measurement of absorptions of UV. UV means ultraviolet and visible radiation. Generally, we are using 180 to 780 nanometer range wavelength by an atomic, ionic or molecular species are known as ultraviolet and visible spectroscopic methods. From this spectrophotometry involves the transition between electronic levels of absorbing chemical species. These methods find applications in qualitative as well as quantitative analysis. For qualitative analysis, UV spectra provide a valuable tool in identification of unsaturated organic compound and elucidate of their structure. However, these methods, UV absorption spectrometric method, is a very important or particularly in the visible range, are mainly used for quantitative analysis of substances of different categories. Now, one more spectroscopy, infrared or IR absorption spectroscopy. Simply that is Fourier transfer infrared spectroscopy. It involves the absorptions of infrared radiations depending on increasing the energy of vibrations or rotation associated with covalent bond. Provides us that an increase results in change in the dipole moment of the molecule. IR spectroscopy can further be subdivided into near IR, middle IR and far IR spectroscopy. Majority of applications lies in the middle region. IR spectroscopy find widespread applications to qualitative and quantitative analysis. However, its most important use has been for the functional group identifications of organic compounds. And majority of the organic compounds which is having a covalent bond, it is most helpful to find the covalent bond. Fluorophotometry. In this fluorophotometry, the energy of photons of incident radiation, absorbed and changes the absorbing species to excited state. Certain chemical substances after excitations can re-emit radiation. Re-emission of radiation can be immediately after the absorptions known as fluorescence. The fluorescence intensity is practically proportional to the concentrations of fluorescent substance. The measurement of the intensity of fluorescence serves useful analytical purposes and the technique is known as fluorophotometry. When re-emission of radiation takes longer time, either it is a minutes or hours or a days, the phenomena is known as phosphorescence and the related techniques as phosphorimetry. One more technique, turbidimetry or nephelometry. The turbidimetry means to determinations made by measuring optical of suspensions of small particles with the help of measuring intensities of transmitted light is known as turbidimetry. When small solid particles undergo suspensions, they are homogeneously dispersed in that liquid medium we are using in the turbidimetric method. The nephelometry is a type of analytical method which is based upon the measurement of intensity of light scattered by a suspensions of small particles is designated as nephelometry. From these turbidimetric and nephelometric methods frequently give erratic results. Therefore, these methods are applied only when the results need not to be very accurate and other precise methods are not available. Finally, Raman spectroscopy. You know that Raman effect, every year February 28th we are going to celebrate the National Science Day. With the contributions of the C.V. Raman, that effect is Raman effect. Raman spectroscopy involves the scattering of electromagnetic radiations by a liquid following Raman effect. It undergoes scattering with the change of wavelength. The shift in the wavelength in Raman effect is caused due to extractions of energy from the quanta of incident radiations and utilized to rise molecules to higher vibration states. The scattered radiations thus has less energy and higher wavelength. Raman and infrared techniques concern vibrational energy change and they are complementary to each other. An important advantage of Raman spectra over IR spectra lies in the fact that water does not interfere in Raman spectroscopy and aqueous solutions can be handled very well. Some other optical methods other than that previously, namely flame photometry, refractometry, polarimetry, find applications in analytical laboratory but are not considered due to their less importance. Next we look at that nuclear methods and classifications of nuclear methods. We shall now examine some techniques which can provide analytical information based on nuclear properties. Which of these properties or combinations of them can be studied suitable by analytical chemistry? The nuclear methods can be grouped into following: the radiochemical methods, radiometric methods, isotopic dilutions methods, activation analysis, Moser-Bohr spectroscopy, nuclear magnetic resonance spectroscopy, simply that is NMR, and mass spectroscopy. These are all the different class of these nuclear methods of analysis. Just we look at that table. Here we mentioned the name of the methods, what property measured, what is the mechanisms involved in that method. In that radio-analytical methods, radioactivity is the property. Radioactive disintegrations of radioisotopes can be measured with high sensitivity and specificity. In that Mossop-Bar spectroscopy, resonance absorptions of gamma rays. That is the property generally we are using in that Mossop-Bar spectroscopy. The resonance fluorescence of gamma rays and involves internuclear energy levels. In nuclear magnetic resonance spectroscopy, positions of signals means chemical shift and their intensity in NMR spectrum. The interactions of quantized nuclear spins with an applied magnetic field. That mass spectroscopy, the position and intensity of signals of mass spectrum, mass change, mass to charge ratio of ionized atoms or molecules. That radiometric methods. The radiometric method, a radioactive reagents, is employed to separate to analyze completely from the bulk of the samples. The activity of the isolated material is then measured. In an alternate, when a radioactive reagent is used to literate the analyte and the endpoint is established by activity measurements. This method is known as radiometric titrations. From that, isotopic dilution method and activation analysis methods are involved in that radioactive methods. That Mossop-Bar spectroscopy, it is a very important analytical method based on the study of phenomenon of resonance fluorescence of gamma rays are known as Mossop-Bar spectroscopy. It involves intranuclear energy levels. An important characteristics of this radiation is the extreme sharpness of lines. That well known that nuclear magnetic resonance, it is based upon the measurements of absorptions of electromagnetic radiation in radio frequency region by nuclei of atoms of certain elements in the influence of strong magnetic field. The analogous method is also called ESR, electron spin resonance. It is based upon the absorptions of microwave radiation by an unpaired electron when it is exposed to a magnetic field. Finally, mass spectroscopy. This method is based on the study of converting molecules into charged particles, their separations on the basis of mass to charge ratio and measurement of the relative intensity of lines by mass spectrum. The instrument used is mass spectrometer, which separates the charged gas molecules according to their masses. Next, classifications of thermal methods of analysis. From this, some property of the system is measured as a function of temperature. Some of these methods, the temperature is used to independent variable, while some of others has dependent variable, say time. The recorded curves helpful in the interpreted the thermal behavior of the samples. Generally, Some common used instruments are mentioned here: thermogravimetric analysis, derivative thermogravimetry, differential thermal analysis, differential scaling calorimetry, thermometric enthalpy titration. These are all the techniques coming under in that thermal methods of analysis. In this table, we mentioned the name of the method, what property are measured, what are functions and instrument. In that thermogravimetric analysis, to measure change in weight, consider chemical compounds, to run a temperature, at what temperature, to variation of this temperature, the chemical compound weight is also changes. That is measured by using this TGA analysis. We are using thermobalance. Derivative thermogravimetry. Rate of change in weight. To variation of temperature, change of weight, just we are going to predict what is the rate of change in weight with help of derivative thermogravimetry. Here also temperature using thermobalance is the instrument. Differential thermal analysis. Heat observed or evolved with the help of temperature. DTA apparatus is the instrument. Differential scanning calorimetry to find the thermal transition, means peak temperature, onset temperature and completion temperature. To change the temperature, DSC cell. Thermometric enthalpy titrations, temperature change, volume of titrant as a functions, titration, calorimeter is the instrument. In thermogravimetric analysis, already we say that it involves the measurement of a mass of a sample as its temperature is increased at a linear rate. Here you see reactant, product, some gases liberated. Finally, plot mass versus temperature known as thermogram. Pursues determinations of thermal stabilities and sample compositions at different temperatures. In that derivative thermogravimetric, differential thermal analysis, differential scanning calorimetry, thermometric enthalpy of titrations already mentioned, explained with the help of that table. The classifications of separations method. In that separations methods involves two. One is classical method and modern methods. In that classical methods, precipitation, distillations, sublimation, formation of complexes. In modern methods, chromatography, solvent extractions, ion exchange and electrophoresis. You know that in that chromatographic method, the separation process in which the applied on stationary phase over which mobile phase is percolated. The solutes present in the samples are separated on the basis of differential migrations. The chromatography can be classified into various kinds depending on the nature of stationary and mobile phase and the mechanism of distributions involved. The chromatography techniques has been used with remarkable success in the separations of inorganic, organic, and biochemical substances. The separations of vitamins, hormones, natural pigments, fission products of uranium and steroids, etc. are separated from this chromatographic method. In that solvent extractions, it is a desired solute can be isolated or extracted by distributing it between two immiscible liquid. In the two immiscible liquids, we are going to separate it with the help of this solvent extractions method. In that ion exchange, the ion exchange is a stoichiometric process in which a solid material known as ion exchanger, when comes in contact with electrolyte solution, takes either positive or negative ions and release the ions like charge to the solution. The solid materials having cations as exchangeable ions are known as cation exchangers, and having ions as exchangeable ions are known as anion exchangers. Ion exchange is a reversible process. The exchanged ions can be replaced by other ions of like charge. The ion exchanger finds great utility in separating the ionic species of similar nature. By using this ion exchange method, generally we are going to extract the rare earth metals and amino acids. Electrophoresis. Electrophoresis means to find the charge of that prepared product. The movement of charged particles in the influence of electric field. That is known as electrophoresis. If the component of a mixture have different velocities under the influence of the electric field, it is possible to separate them. This method has been used with remarkable success for the separation and characterization of polysaccharides, nucleic acids, hemoglobins and other high molecular weight compounds. The small organic and inorganic ions can also be separated with the help of these techniques. That is called what? Ionophoresis. Now I am going to summarize that unit 1. From this unit you learn the general perspective of analytical chemistry, the concentrated with the detection, determination and separations of substances. It deals with the development of methods of chemical analysis. Applications of chemical analysis are to be found everywhere in a scientific and industrialized society. You learn that gravimetric and volumetric, known as classical methods, developed mainly in the second half of the last century, are known as the modern methods of analysis. The analytical methods can be classified in various ways according to the criterion adopted. The major classifications gives chemical, electrical, optical, nuclear, thermal and separations methods. These methods can further be classified according to the quantity being measured. Utility of analytical technique is to be found in various fields, has the key to the solutions of a variety of scientific problems. It is a chemical discipline with interdisciplinary character providing valuable information in many branches of science and technology. The recent trends in analytical techniques have followed closely the development of new measuring instruments to find faster and convenient ways for sensitive and selective determinations of desired constituents. Instruments can be designed that will automatically perform many or all the steps of an analysis. Okay, this is the unit 1, block 1 under unit 1. Thank you.